Okay, I picked up a little screen from the supply house. It comes in this little envelope. That's what the inlet screen looks like, and that's got to go on the inside inlet to the expansion valve. You don't want to put a valve together without that in there. It's pretty important. And that's the inlet right there. And I'm going to push it all in. And I'm going to solder this. Got to clean the copper good. The same.
So, I mean, we want at least 10 cases. So if you wanted to, you got 5 cases.
Okay, I'm draining the oil out of the compressor now, and it turns out that it's let's see if I can do this. It's the old mineral-based oil. Sunnysell 3G is what it was, and what I'm going to put in there is the new POE oil. Now this Sunnysell P3S, the old mineral-based oil, alkybenzene oil, and the POE oil have the same lubrication factor, which is about, I believe it was 150 viscosity. That's how it was rated. So I'm just swapping the type of oil. The oil's draining out slowly. It smells like old mineral-based oil, and it looks a bit darkish. Should look like Wesson oil, but it's probably either from old age or the fact that it was exposed to a lot of heat. This compressor apparently was put together in 11/15/99, so we got some miles on this guy. Quite frankly, the fact that it was through all the heat from the fire, the age of it, plus the fact we have water in the system, I don't know how this poor compressor is going to make it. The first week, we can get by the first week with it if it does run. I haven't even run it yet. But if we get by the first week, we might have half a chance but it's got a lot of years on it alone. Okay, well, I almost got the oil drained out of it. I have to shake the compressor a bit to get it to drain. Whatever's in there has got to come down to this low spot here, and it's probably some sitting over here. So I'm going to have to use 2 hands and tip it. Okay, I reinstalled the compressor. I swedged and I brazed it here on the low side and on the high side in the back, if you can see it back there. Rebolted it down. I had clipped these wires, and what I did was, these are male-female crimp-on connectors so that they can be pulled apart again if I had to. And it's just neat and easy way to take that apart rather than I'm trying to unscrew that and messing with that. And I've got my Appion Schrader removing tools here in, and I'm pulling my vacuum. I changed the oil on the vacuum pump, and I filled it up right to the gauge here. And of course, when you start it up, it always goes too high, and oil squirts out the handle, but that's normal. I pulled out my old thermal. Haven't used that in a while. My thermal vacuum meter, and it's started. I just started the vacuum. It'll be a while, and if there's water in it, it'll be a long while. I put a new dryer filter on it, got that tightened up, and I added a Schrader over here. I'm going to, I drained the oil out of the compressor, and it looked like burnt varnish color kind of thing. Here's something that just, I just got a call from, I just got a call from New York, and this is going to be a selfie here. Got a call from New York, and this Chinese guy has a restaurant there, and the guy bought an ice machine. The Chinese guy, there's probably a couple of them, they bought an ice machine from Grainger Supply. They hooked it up, got it running overnight. They came in this morning, and the ice machine wasn't working. And here it is, it's close to 3 o'clock in the afternoon, and they couldn't get it running, which means that they were playing with it themselves. And I've seen this before from Chinese restaurants. I can just picture the Radio Shack multimeter there, and jumper wires, and the circuit board I'm sure is fried by now. But and of course they're gonna claim that it should be in warranty. But it's way to go, Grainger. The guy wanted me to. He ran into trouble with it, so he figured he'd go online. He typed in Manitowoc, and my number came up. So he called me, and he wanted me to analyze it over the phone, and so he could find out what was wrong with it. Simple, right? No, it's not that simple. It's like 10 things that it could be. You have to literally be standing there with your gauges and your tools to figure out what the problem is. It's not easy. I said to him, this ice machine is not like going to Sam's Club and buying a little wine refrigerator and plugging it in. It's difficult. And I said, you need to have a refrigeration man analyze this and check it out. And I said, and you went to Grainger and you eliminated your refrigeration man from the equation here, and you're going to call him in now, and he's probably going to be pissed off. I said, you probably just screwed yourself. I wouldn't touch it. And then I said, I got to go, goodbye. And I hung up on him. It was a bit abrupt, but it's happened to me so many times. And it just ticks me off when here the guy, he eliminated the refrigeration man from the equation, bought it from whoever he can get cheaper, and probably, as a restaurant, he probably needed a 450-pound ice machine, or 350-pound ice machine. He probably bought one of those little 110-pounder under-the-counter ice machines, and it's if you want to save money, it's going to cost him more money now, because he probably screwed up the machine, jumping the circuit board out or whatever. And how's he going to get warranty on it now? If you're watching this and you have a restaurant, when it comes to an ice machine especially, they're difficult. Have your refrigeration man, buy it from your refrigeration man. Let him pay his rent or his mortgage payments. He's got to be able to pay his bills. Don't eliminate him from the equation. Don't be cheap. Don't be cheap. Do it right. Okay, let me get back to this. I have to run the drain line now and run the electric lines, and I got a lot of work to do on this thing yet. But we got the compressor back installed, and probably start it up tomorrow. I'm gonna run this long vacuum on it today. I'm gonna put nitrogen in it. I'm gonna run another long vacuum on it tomorrow, and then I'll start it up. But that's where I'm at. That's a picture of the greenhouses, all the little plants. And as they get older, they all throw off heat actually. It's a big heat load on a little walk-in cooler. And what they're going to do is they're going to put those little plants all in here and keep them from blooming until the last second, then ship them out and let them bloom in the store. But that's what we just did. And here's a picture of the greenhouse. Look at that, Smokey the Bear. What a little humor. The picture of the fire that this compressor was exposed to. It's quite a bit of fire. There's a lot of heat. But luckily it'll be okay. Okay, this is the next day. I've had this vacuum running about 20 hours now. It's like 3 o'clock in the afternoon. And it's 11 or so, 10:30, 11. And let's see, this gauge, I'm reading 300 microns. And this is hooked up on my low side here, on the compressor. And on this gauge, I'm reading 438 microns. And it's been running all night long. And everything looks pretty good. I'm pretty confident I got most of the water out of it. My sight glass, the moisture indicator, is indicating dry. That purple color is good. If it was pink, it wouldn't be good. But it's that purple color, so that's very good. Of course, I'm not circulating any fluids through the system, refrigerants through the system. So what I did yesterday was I removed the oil out of the compressor, and it was pretty nasty looking. And I haven't put new oil back in there. I wanted the vacuum to pull on whatever residues that were in the system. If I put new oil in there, it would be in the way for any residues in there. I wanted the residues to be exposed to the vacuum so they evaporate off. But my vacuum pump is hooked up here on the low side connection, and that's taken care of. I have a solenoid valve here that I have to be concerned about. So the low side is from the compressor all the way downstairs through the evaporator coil and back all the way up to this side of the solenoid valve, and that's what this hose is taking care of. And that's where I have the 430. It's fluctuating between 435 and 438. Hasn't gone down any lower now. What I'm going to do is change the oil on the vacuum pump and finish up installing. I have to install the drain, and I have to connect the wires up here. I ran the cable. That's the 230 volt cable. It's going from this condensing unit up here down to the evaporator coil, which is just right over here. I got to connect that yet to 230 volts. I changed the fan motors from 115 to 230 volts. That's all done inside, and they're put together. But that's now my other hose is hooked up on this side of the solenoid valve, between the solenoid valve through the condenser and to the valve plate of the compressor. So this side is the high side of the compressor. I don't have a vacuum gauge on that side, but it should be pretty good, I would think. And there's a little conflict here between 300 microns and, which is low side, and this is the other side of the low side through the evaporator coil. Okay, I just changed the oil, new oilers. I just wanted to show you good to see the oil came out milk colored. And there's probably water vapor mixed in with it. But that's goes in nice and clear. And you can see how clear it is when it starts out. Let's see. It starts out nice and clear. Good vacuum pump. Platinum. JB. Made in America. USA. USA. And, that's... I'm going to pull the vacuum on another couple hours while I'm finishing the wiring, and then I'll put the 407F in it and see if everything works. Alright, this says I'm just below 300 microns there, and this one says I'm a little over 300 microns, but I'm going to let it run longer. Now normally you don't want to run a vacuum below 250 microns because the oil starts to fractionate and break down under 250 microns, but I don't have any oil in the system right now, so one of the reasons I left the oil out. And what I'm going to do is I'm going to put Subco in the system. I like this stuff. I use it. It's in a lot of my videos. I've been using it a long time. A lot of confidence in this, and this will dissolve any waxes or cruds or any residues that might build up in the expansion valve and capillary tubes. We don't have very many capillary tubes on the system, but it'll keep sensors clean, and it'll keep the inside of the tubing clean, which is kind of important, especially with the condition this system was in. Now the wiring, I just connected, got the wiring done. And this is my ETC temperature control, and it's a good control. It'll show the digital readout of the actual temperature at all times. And the way this is set up is, let me see, the wiring diagram is up here someplace. Okay, this is pretty simple to understand. What I did was I used the 240 VAC. That's what this running that is, a control circuit to the time clock, to the circuit board pretty much. It's 240 volts. And I got that off the top of the contactor up in a control panel. And this is the control circuit down here, and it shows you connect it between common and normally open. That's for the control, make and break contact. And that's wired through the time clock, I believe it is. It gets the feed off the time clock, number 4, comes down through this control and then back through this control circuit. Really goes to the solenoid valve at that point. But it's pretty simple. But one of the nice things about this control is it's got a lockout on it right there. So if you have a problem with employees playing with the buttons on the control, you can lock them out. I'll leave this unlocked because it's up high and they're just the owner. Although one time I did lock an owner out. I was getting service calls. I had to go there and just adjust the clock, so I locked them out. Probably drove them crazy. So I had to put that cover on it. And now we'll go up here and look at the control panel up here. Okay, this is, you got the main disconnect box over there. Unfortunately, there's fuses on it. The electrician brought a big heavy set of wires in. They were going to change this motor on this truck. It's a 5 horsepower motor, so he ran way oversized lines. But it's number 8 wire. It's pretty heavy. And anyhow, this system doesn't draw like 8 amps, 10 amps, something like that. But this black and the white are the main legs coming in, and I thimbled them to the existing wires, and it goes to L1 and L1 and L2. Comes out of L1 and L2 and goes to the compressor, the relay, and the capacitors, which I have to test yet. Control circuit, the yellow wire here is L1. Let me see if I can zoom in a little bit. Okay, this control wire here is L1. Goes to the time clock. Goes through the time clock to 4. This blue wire goes to the temperature control contacts, common. Comes out of common as normally open. They normally open right here. Comes back. And then from here it goes to the solenoid valve over there. And that's the resistance. You can't have it go directly to L2 or it'll be a direct short. You have to have some kind of resistance, whether it's a motor, a heater, some sort of a resistance, and that's the resistance. The coil is the resistance. Comes out of the coil back here, and quite a few years ago you had me put this pump down switch in. Goes to the pump down switch, comes out of the pump down switch, and ends up back on L2. So it goes from L1 through the circuit, through the solenoid valve, through this switch, and back to L2. So L1 to L2. It's a completed circuit. The solenoid gets L2 here, comes off here, and goes through the pressure switches. You've got 2 pressure switches, one on the high side and one on the low side. And it goes to the low side pressure switches, or it goes to the high side pressure switch first, comes back to the low side, right, okay, here. The black wire goes to it's the high side pressure switch, comes back out of the high side pressure switch right here. The black one's the high side. Goes to the red wire through the low pressure switch right there. Comes back out of the low pressure switch and goes to L1. So it's L1 to L2 through the coil here. And that's for the pump down. This controls the pump down. It pumps down at whatever the setting is on this low pressure switch. but hopefully I didn't confuse you too much on it, but it's just fairly simple. And a time clock, I have to see if this is functioning. Wheel's turning pretty okay. It's a little stiff. I might loosen up. I might have to change it even. It's pretty common control. It's an 814520. That's a very typical time clock. Okay. And I'm just going to let my vacuum continue. 371. And I'm just a little under 300 on this one. So I'm pretty confident I have 95% of the moisture out of the system. I just want to let the system run a little bit longer and get more moisture out of it before I start it up. I may change the dryer filter. I may not. I mean, if I get most of the moisture out, I have to put the oil in the system yet. And I'll put that in right directly here into the compressor sump. I'll pump it from a can right into it. I have to do that yet. But right now I'm going to go install the drain, PVC drain on this system. Okay, looks like that's as low as we're going to go with the vacuum. It's been almost 23 hours straight. So that's the end of the vacuum. Now I'm going to put gas in the system, bring it up to 0 pounds pressure, put oil in the compressor, and then add the gas to 407. Performance 407X. Okay, I'm about to put my oil in. It's Copeland approved polyester oil, 32.3 max, and I measured the amount. I used this coffee can for years. I use the rings. I measured the amount, and I'm going to put Supco in. People ask me how I get the Supco in the system. I just add it to the oil. That's about good. Just use your judgment. Supco has a smell to it. I like it because I'm used to it, but some people don't like it. And fundamentally, this is my oil pump. It's a thermal engineering it's made, and I just pretty much just pump the oil in at this point. It's not hard to do. And it's just going to go right into the compressor. And it's as simple as, you can see it from where you're on here. It's as simple as just draw it up into the pump and then push it into the compressor. I brought the system up to 0 pounds pressure, put some refrigerant in it. So I'm not taking any air into the system. And this is fresh virgin oil. Don't want to go any more than that. It's good to keep this pump clean. put new Schrader valves in. I put one in here and two in the suction and discharge. Okay, that's good and tight. Okay, I checked the capacitors out, and the run capacitor was bad. I changed it. Another one in there, and my contacts in the 2-pole contactor are chattering. They're making a lot of noise, so I'm going to put another contactor in there. I'll just show you. But otherwise, everything else is running really nice. The compressor's running very smooth. And let's see. It's actually a little quieter than it was a couple minutes ago. Before I change this contactor, let's see if we can push the points in a little bit. Contactors like little silver buttons, and sometimes a little tit will stick out on it. That bad, actually. Gotta be a little careful poking around in there. The power is on. I unscrewed it from the wall. That's part of the noise that it was making when it was on the wall. It's just a little bit too much vibration. I'll change it. It's not that hard to do. It's easy enough. But what I carry around, a lot of my contactors are 3-pole contactors. So rather than having 2-pole and 3-pole, I'll just carry the 3-pole around. It just makes stocking a little easier because there's a lot of different ones too, voltages and amperages. This thing's only drawing, this was around 10 amps, wasn't much. So this is a 30 amp contactor. Doesn't hurt anything to have a little extra amperage. It's nice the holes line up if I can get at them. Okay, it's a little congested here. Okay, I changed the contactor. That's nice and quiet now. Now what I have to do is I have to see if the time clock is turning, and I put a mark on it right there in conjunction with the pin, and see if it's, I'll come back and look at it in 5 minutes or 10 minutes, and hopefully the arrow will be over here. So now I'm going to go, I just have to charge the system up with gas, finish charging it. But it looks like it's doing pretty good. Compressor's nice and quiet. It's only drawing the fans, both the condenser fan, the compressor, and the 2 fans downstairs inside the evaporator. The total is only 6.3 amps. 6.25. That's very nice. The Subco does a nice job. I like that a lot. It really makes things run very smooth. And it's a cleaner too. It cleans up stuff, keeps things open. Okay. The last thing I want to do is, I'm looking at the expansion valve right now, and I have 13 degrees inlet outlet difference. The delta T on the tubing is 13 degrees, which is pretty good. But what I want to do is, I want this to be very humid in here for the flowers. If my delta T here is up to 15, it's going to dry them out. It's going to take the water out. But by going down to 10, it'll keep a lot of water in. So the way to do that is, I don't know if you can see this very good. But clockwise increases, counterclockwise decreases it, and that's what I want to do. I want to decrease it. So let's see if we can, if that's any better. We got 13.4. And the 13. Nine, 12.8, 7, 12.6. Now, a question I get asked a lot is, where do I put my probes? One is on the small tubes, distributor tubes, about 6 or 10 inches from the valve over here. And the other one is on the outlet, the pipe going out by the bulb, the thermostatic bulb. It's near the bulb. This is on the inlet, and that's on the outlet. The outlet's always warmer, so you subtract the inlet from the outlet, and it should get, we want to get 10 degrees. So I'm at 12.7 right now. And we're dropping. What I'm doing is opening the valve up, is what I'm doing. I'm letting get more refrigerant, liquid flow through it. Now when I first came here, I could see after the valve here, the first section had some frost on it, which means that it was closed off too much, it was restricting. Now it may be debris in the system. I hope that's not the case, but we'll find out if that's if there's moisture in the system. What will happen is it'll plug up the needle port in the valve, and the valve will just get plugged up, and then the suction pressure will drop, and it'll kick off on its low pressure switch. everything in here will get warm. And a day later, the moisture will have warmed up and defrosted and moved on. And then it'll be cold again. So when you have intermediate temperature swings, too cold one day, or cold enough one day, and too warm the next day, and then the next day it's warm again and then cold. It's usually moisture or wax plugging up the expansion valve. Now I might have to put a little more gas in the system. The cyclast showed full. And now that I'm opening this up, with the valve closed off like that, the refrigerant will back up to the cyclast and it will show full. And by opening the valve up, the cyclast the refrigerant will flow through the valve, and it may show that it needs a little more gas. I have to check my head pressure and discharge pressure. I have to pump the system down yet, make sure that the receiver tank will hold the amount of gas, because this system is a pump down system. You have to check the pump down. So I'm down to 12, 11. I want to go down a little bit more. And I'll let it run, and I'll check this again back with this, make sure it's stabilized. See that I'm at 11.7. As this box gets colder too, this value will drop some. So I may leave it right here and come back and check in a little while. So I'm at 11.2, 11.3. So I'm just going to come back and check it in a few minutes. Okay, the system's doing pretty good. I put my labels up here. 470, DOE 8, and my head pressure is 236, suction is 67. This was R22, so that's good R22 pressures right there. A little bit high. Suction line is nice and cool, not cold, not warm. Compressor's drawing good amps. The liquid line's not hot, it's warm, lukewarm, which is right where it's supposed to be. A little bit warmer than room temperature is what I always go for. And my suction filter. I think this is good. We put almost a 12-hour vacuum on it, and it doesn't seem, it looks like I got the moisture out of it. I'm pretty happy with it. The system's running nice. The compressor sounds good. It's from 1999. It's a lot of miles on that compressor. But and it went through a fire. So luckily it's okay. Looks like it's doing good. So I'll find out if there's moisture in the system tomorrow. I'll get a call, or the day after I'll get a call saying it's warm. And if that's the case, I have to come back and change the dryer filter. But if you look at the moisture indicator on the sight glass, it looks very good. This is the color for dry, and it's pretty close to that. And that's water. If there was moisture in the system, it would be pink. But I'm pretty happy. I think we got it. It's full of gas. It's flowing good. All I have to do, I'll pump it down and see if it goes on the frost okay. But that's about it, guys. Well, that's about it, guys. Later.